is exceptions and error handling. We hear this a lot when we talk about Go, right? In particular, people hate this bit of code for some reason. Like, people really have like a bug up their butt about these 3 lines of code. And it just blows my mind. I don't understand it. But the things you'll hear a lot are, it's repetitive, right? It litters my code base. It litters my code all over the place, this stupid thing. I wish I could use exceptions to trigger a workflow. What? Like, by the way, you should never be using exceptions to like define your workflow. That is a terrible workflow. Think about what you're doing there. So to these people, I would say, yeah, like these things are littered throughout your code, but they give you a lot of flexibility. Let's look at a little bit of code here. Look at some Java, I got some Go. I'm not picking on Java, by the way. It's a very easy to understand kind of, well, I guess if you consider that easy to understand. Okay, that was picking on Java a little bit. But Java represents a very kind of traditional try-catch kind of syntax. Both these bits of code, by the way, do pretty much the same thing. They read a file and they print off each character to the screen. Not about that. What we're really looking at is kind of this try-catch syntax, right? There's a finally here, there's another try-catch inside of that, right? This is pretty common. In the Java world especially, right, we're forced to capture every exception. Has anybody here done Java? A lot of people. Okay, so you all know this, right? If the method defines that it throws 5 exceptions, you have to capture 5 exceptions and handle them. So I'm not sure how that's not repetitive and littering your code, but apparently that's okay because you can write a workflow around it. In this situation over here, what I like best about it is, A, I get to decide whether I'm going to handle an error or not. I know that there's an error return. I get to decide whether I want to handle it, and I get to handle it in line, inside my code. Right? I can fix my problem here and then continue through my workflow. You know, in this case here, if there's a problem reading this, which is what happens in one of these 2 methods, I'm not sure where, this gets thrown, and then what am I supposed to do? How am I supposed to fix this problem and continue my workflow again? Right? It's a lot more difficult in a try-catch situation. So point that out to somebody. Explain how here, I'm in control. If you have a config setting, for example, I'm reading a config file. Config file doesn't exist, it's poorly formatted, what have you. Fine, I capture the error, I set a bunch of defaults, and I continue on. It's as simple as that. It's harder to do here. So just point that out. Yeah, they're littered everywhere. Tell them to set a vim macro or some other little key command in their editor to print that out. That's what I do, and move on with life. Who here has heard that Go is stuck in the 70s? Nobody? Come on, you must have heard this. Come on, look, Hyde is wearing a little gopher shirt. How cool is that? I charge for my photoshopping skills, by the way. And you notice he even has a little afro because it's 70s. That took me like 2 hours. I'm so embarrassed by that. I always do like 1 slide with my terrible photoshopping skills. So anyway, when people say that Go is stuck in the 70s, what they're really saying is, why can't it be Haskell? I love Haskell. I want to use Haskell. To that, I usually say, no one uses Haskell, move on. Like, it's a nice language, I get it. It's pure and it's academic and it's beautiful, but no one uses it, move on.
That's my last name.
Sorry. Haskell equals troll face. So yeah, every time someone says that, mention that. But no, I mean, the syntax, yeah, the syntax is very reminiscent of things like C and C++, as we know. And that was purposely done by Rob Pike et al., right? They like those languages they know. But they also said, by coming up with this familiar syntax, it'll be easier for people to learn, right? A lot of people have had experience in these languages that Go is modeled after. It's easier to pick up. You can sit down, you're like, okay, this is not that unfamiliar to me. I feel comfortable in it. It's not some crazy new syntax that you have to learn, you know, where, I don't know, the number 8 is a delimiter on each line and like weird stuff like that. You know, and it's new line spaced and whatever. But it is a very modern language at its core. So when people say that, you know, tell them about concurrency and modern tooling and maintainability and scalability. These are all things that Go was designed to do to face the modern world. Right? These are all modern problems. You know, C wasn't really thinking about concurrency and tooling when it was developed. Go is all about these things. So these are important tenets to Go that make it a modern language despite its 70s appeal, or 70s look and feel. Rails. This is typically how I feel when I do Rails. But I get this a lot coming from the Ruby world, right? I've been out there being a big proponent of Go and web apps for the last couple of years in Go. And I get this question a lot all the time, what's the Go equivalent of Rails? Or what's the Go equivalent of Django? Or insert your framework from your language here, all right? There are a few. Has anybody tried any of these? Bigo, Revel, Martini, Gin. Yeah, I mean, they're not like terrible, but they're not picking up adoption the way Rails did. And there's a lot of reasons why they're not picking up adoption. One of the big reasons is that Go is not a highly dynamic language. It doesn't have the magic that a Ruby or a Python does, for example. So to do those same tricks that Rails does or Django does, you really have to jump through a lot of hoops in Go to make that happen, to make that magic kind of happen. And when you do that, you introduce a lot of these problem areas. You introduce a lot of complexity in your code. Reflection. That's the only way you can do this magic in Go, and reflection is generally frowned upon. Rob Pike has said time and time again, if there was one package he wished he could remove from the standard library, it's reflection. He said it was a bad idea, never should have done it. He curses himself every time you see somebody use it. When you do reflection, you immediately slow down your code by orders of magnitude. Reflection is incredibly slow. So if you're thinking about using reflection for anything, like think twice. Is there a better way to do it than reflection? And hopefully the answer is yes. And with reflection comes instability. You lose the nice kind of stability that Go gives you through the compiler checks and GoLint and GoVet and all the tooling that goes around it, because now you're talking about God knows what. You don't know what you're actually going to be handling when you're dealing with reflection. So that's kind of why these tools haven't taken off. So when I was on a panel last year with Jeremy Saenz, Code Gangsta, who did Martini and Negroni, Bill Kennedy, GoLang.net, wrote Go in Action, Maria Lopez and I were all, Veronica Lopez and I were all on a panel, and this question came up, and Jeremy and I are both big web app people, obviously, and Jeremy wrote Martini, and the question of what should I use if I want to build a small web, I have an idea for a website, a web app, I want to build it, what should I use? And honestly, we kept saying Rails, like just use Rails, and there's a lot of reasons why we said this. I've got Rails in quotes here, by the way, because I want people to understand I'm not picking on Rails. Insert your framework of choice here. Rails kind of was the king of frameworks. It started this whole magic convention over configuration kind of framework thing about 10 years ago that everybody's kind of followed suit with. But Rails is really, really good at things like rapid application development. True story, about a year or so ago, a friend of mine and I started a company called PaperCall, which does CFPs as a service for conferences. We started doing SOA, we started with Go services, all sorts of stuff. Like 6 weeks went by and we had like a half dozen services and you still couldn't submit a talk. But it was beautifully architected and fast, oh my God. But you couldn't do anything with it, which is probably why it was so fast. So we switched to Rails, and like 2 weeks later, we had the first version of the site out the door. And Rails is really good at that, like really, really good at that. It's really good at prototyping. Just I have an idea, I throw a few gems in there, I run a few commands and throw Bootstrap on it, it's out the door. Go is not very good at that, and I'll talk about that in a minute. Rails is great for small teams, right? You can couple people, you don't have much time, get it out the door. It's also good for small scale. Rails can scale. I'm not going to get into that argument. Thankfully, this isn't a Rails room, so I don't have to have that argument. But when you're a small shop, you don't have a lot of traffic, you don't have a lot of users, a Rails, a Django, insert framework here, works really well, and that's honestly what I would choose. Go, on the other hand, was designed by Google, a company that has performance issues like none of us will ever have, the exception of maybe the Akamai people. The rest of us could pool all of our user requests for a lifetime and probably not hit Google's kind of hourly requests rate. So they built something that's going to solve their performance problems and pretty much any performance problems after that. It was designed for maintainability. right? Without magic, with all that meta programming involved, you can sit down in a piece of Go code and look at it and understand exactly what's happening. You know, you understand where the packages are coming from because they're listed at the top. Hell, you can even go and find them on the web. It tells you exactly where to go. It's easy to figure out what is happening in a Go program. I look at a Rails app sometimes and I'm like, where'd that function come from? Don't know. Let me grep for it. Oh, it doesn't exist because somebody's magically creating it at runtime. Right? You don't have that problem in Golang, right? You're like, where'd that function exist? Oh, Go def. Oh, there it is. That was fun. Like, it's easy to maintain a Go app. And because of that, it works well for large teams. Google is known for having a single repository for all of their Go apps. Did everybody know that? They have one source repository for all the Go in their entire ecosystem. I would say they've got a large team of people. They've got at least 3 or 4 people working on Go stuff. So they know a thing or two about it, I would say. It is also designed for, like I said, large scale problems, large scale distribution, and things like Rails just really aren't. So tell people, what's the Rails for Go, and the answer is it's Rails for Ruby. Use that. But Go is great for when you outlive your Ruby days or outlive your Rails days. Go is a place to go for it. Does anybody know who this is? Come on. Think about it for a second. This is a Go talk. Pointer Sisters. Yes, who said it? Nice. Pointers. I'm giving this talk in India and Dubai next month.
Good luck with that one.
Good luck with this one. I think Homer Simpson will work. I'm not sure about the Pointer Sisters. I couldn't resist. So pointers, people freak out about pointers. Oh wow, do they freak out about pointers? And I can't blame them, right? I mean, the first thing that comes to your mind when you think pointers is what? Pointer arithmetic, right? Null pointer exceptions, pointing at bad bits of memory, writing over memory. It's scary as hell. I've luckily never really worked professionally in a language that has had pointers. Java did like to throw null pointer exceptions despite not having pointers. That was kind of cool. It's like, oh, I got null pointer except what? Like, well, how do I create a pointer? Oh, you can't. Okay, then that makes sense. I did some iOS when it first came out, and that had memory management, and that kind of freaked me out. I'm like, I don't understand this. Can't they just take care of memory for me? So when somebody comes from a language that is, a GC language where you don't have pointers, you don't have, memory management, people get freaked out when they hear the word pointers. They think this is going to be some computer science kind of problem that they're going to have to solve and do all this mapping and the slide rule out, the abacus going, they get their DEC mini computer cranking out, stuff. And it's not true at all. Pointers are really, really simple in Go. And just, when they get stressed out about it, sit them down, give them a cup of tea, wipe their brow, say it'll be okay, stroke their hair. People like that. Talk gently to them. Say, let me explain pointers to you. There's 2 things you need to know about. Use a calm, soothing voice, by the way. There's 2 things you need to know about pointers. The first one is they're there for performance. They help us with performance, right? I've got 2 functions here. I got by value and I got by reference. Second one takes a pointer. The first one takes a direct value. The difference between these 2, apart from little asterisks that represents it being a pointer, is the first one gets a full copy of the memory that represents, in this case, image, right? So let's say I have an image that is 100 megabytes. I've read it into memory. I want to pass it to this first function. If I pass it as is, as defined here, it's going to get a copy of that 100 megabytes. So it's going to be 200 megabytes now sitting in memory. In the by reference case, now he's got a small little pointer. So we've saved a lot of time, we've saved a lot of memory, and not having to copy all this memory around. And that's like kind of the big thing there, right? It's a huge performance gain by having this access to pointers. Because of this, though, because we have pointers, we also have a second gain that people don't really talk about, but I consider a huge win, and that's kind of read-write access to my data. When if I have 2 functions there, read-only and read-write. And when I want to control what someone can do with my data, I define whether it's going to be a pointer, whether it's going to be value. So this first one here, I give somebody a copy of my image, and it's a copy. They can wreck it. I mean, they can just go to town on it. They can, I don't know, they can. I had a really gross image I was going to throw out there, but I decided not to. Analogies are not my forte. They usually go very blue very quickly. But in the second one here, I've got a pointer. So now because I have a pointer directly to the original memory, I can mutate it. So maybe in this function here, I'm going to add a watermark to my image, for example. Whereas in the first one, maybe I'm just going to create a thumbnail copy of it. So that's a huge benefit. So when you're talking to somebody, calm them down. Make sure they've had a nice cup of green tea or whatever, stroke their hair and say, pointers are good, they give us performance, they give us some security around our data, there's no arithmetic, there's no math, everything's okay, Santa Claus exists, the Easter Bunny's real, all is good in the world, and then, move on. What is it? Opinions. You know what they say about opinions, right?
Everyone's got one.
Everyone's got one. That was the clean version, wasn't it, Johnny?
Yes. I preempted you there.
You did, yeah, thank you. I have a hard time keeping my talks G, by the way. So, in case you couldn't tell. So, what I love about opinions is, has everybody heard that the Go is too opinionated argument? Have ever heard this one before? Go is, I hear, so if you go on Hacker News or Reddit, there's actually a Wikipedia article, not Wikipedia, GitHub site where someone posts all the negative articles about Go, and they list the negative things that people say in the articles, and like too opinionated was one of the top things that people say about it. What I love about this argument, and I've got this argument, people have said this argument to me, it's like, it's too opinionated, I hate Rob Pike's opinions. The irony of that sentence like totally escapes the person telling me their opinion about how they hate how opinionated it is. It just blows my mind, and I'll point it out to them, and they'll be like, "Screw you! I hate your opinions too." And I'm like, "Okay, Trump," and I just walk away. Yeah, it's opinionated, but you know what? Like Rails is opinionated, Django's opinionated, Java's opinionated, Ruby's opinionated, PHP's opinionated, JavaScript's opinionated. Their opinion was, "Let's make a shitty language." Hey, they delivered. It's on the tin. Sorry. Like no one's arguing, so clearly I had a nerve. Yeah, it's opinionated, and it's the opinions of Rob Pike et al., right? They decided this is the way we think Go code should be formatted. This is the way our handling is going to happen. This is the syntax we like. This is the way we like to do concurrency, channels, what have you. But every language has that. Python said, well, we're going to make our app, we're going to make our language, white space significant. That was a decision. That was an opinion they had. Whether you like white space or not, if you want to use Python, you have to accept that opinion. If you want to use Rails, you have to accept all the opinions of DHH, most of which are terrible. But that's a whole nother talk about DHH. But everything is opinion. Every library, every language, every framework is the opinion of the author as to the way they think it is best to do the job. So explain that to the person. Again, if they're a hater and they're like, "Screw you, my opinion's right," then just walk away. But otherwise, just explain, yeah, it's got opinions. If you like the opinions, use it. If you don't, keep doing whatever's working for you. My last talking point. This is the big one. Generics. Has everybody heard of generics before? Yeah. I love this picture, by the way. I love the white labeled bottles of booze. Like somebody makes Scotch whiskey. That's it. That's the good stuff. That's what I drink, by the way, in case anybody's looking to buy me a bottle. It's $3.95 at Walmart. I highly recommend it. So true story about generics. If you didn't know, if you say generics 3 times into a mirror, Rob Pike appears. And he is pissed. So I really would not say it. This is like, I kind of call this the nuclear bomb kind of argument, right? This is the one they'll go, generics, they mic drop and they run out of the room. You can't even argue. It's like almost pointless to argue with somebody who brings up generics. Yeah, Go doesn't have generics. Go will never have generics. That's been stated a million times over. I worked in Java before it got generics, you know what I did? I shipped a whole hell of a lot of code. Never stopped me. Ruby is, I kind of guess, the opposite problem. It's all generic to a fault. But you know what? I've shipped a whole hell of a lot of code in Ruby too, and it's never stopped me. I know people who shipped code in every language that doesn't have generics, and they've always done a pretty damn good job of it. You know, the big argument you get is, well, I can't do my MapReduce function without generics. It's like, how often are you writing MapReduce functions? That this is a huge problem for you. You know, in that case, there's a few things you can do to solve your I need generics problem. One, think about your code design. You know, are you coding this the right way? Is your architecture good? You know, is there another way that you can code this that gets rid of the need for generics? What about interfaces? Will interfaces solve your problem? Likely that they might. In the case that those first two don't work for you, there's Go generate. Yeah, it'll generate some code that is now sitting there in your app, and ooh, maybe you have to write the same function twice for a different type. But who cares? It's a small amount of code, right? If you're writing anything pretty much other than a MapReduce function using generics, you're doing it wrong. That's a bold statement. And I'm probably a million reasons why that statement is wrong. But I'm opinionated too. So take that to the bank. So just talk to them and say, yeah, it doesn't have generics. You know what? People are still shipping code. Google is still shipping a whole hell of a lot of Go code. You know, all these, there are plenty of companies. Docker is still shipping plenty of good code. Influx is still shipping plenty of good code. The folks in this room are still shipping plenty of good code without generics. You can do it. What did people do before they had generics? You think assembly had generics? No, they sent people to the friggin' moon with that, okay? You can probably get around not having generics in your code. So with that said, you know, haters gonna hate. I said that right from the beginning. Walk away or skip away from those people. I'm not quite sure. I don't even know what he's skipping over, like a puddle or something? And I'm only just now realizing he's a priest. So I don't know what that's about. That's what happens when you do a Google image search for haters gonna hate. You get a priest jumping over a puddle, I think. So just walk away from those people and don't let them bother you. And that is it. That's all I have. Questions? I sing and dance too, folks. Do the old soft shoe. Yeah.
A lot of those questions are technical.
Mm-hmm.
So what about for business people, like bosses,
Less engineering use and more of the lines of, will this work for us?
Yeah, they may not know what generics are, but they are.
Right. They are in charge. No. That's a very good question. So how do you kind of deal with the boss? Obviously, depends on the specific questions that your boss asks you. The big one that I always find works really well is that argument I made earlier about Go and Google's problems, right? This is a company, like I said, who has more scalability issues than any of us will ever see in our lifetime. And they said, this is the way we're going to solve it. So when you're talking to your boss and you say, look, we've got this scalability problem, we got this performance problem. I think Go is the right solution for it. And they say, well, why do you think that? And say, well, because one of the biggest companies in the world said this is the way to solve your problems. And I think it'll work for us. And just talk about some of the other benefits. You know, the single binary is a huge benefit. Managers love to hear that sort of stuff. Say, look, I can generate a single binary, no dependencies, distributed amongst the team. We can give it to our Windows users. All these sorts of things. It's a huge win. It's easy to deploy because it's a single binary, right? Managers love that sort of stuff. They love, look, this stuff, it performs well, it scales well. Because of the format, the tooling and stuff around it, it hardly ever goes wrong in production. Go out there and do a little research, show them some numbers, and some of the testimonials about people dealing with performance and stuff in Go. And the production up times and stuff in Go. Engineering managers love that. They love to hear that it's not going to break, and it's fast, and it's easy to use and easy to distribute and easy to scale. They love that. Yeah.
I actually had exactly that conversation.
Oh, really? What'd you say?
Some of it was around easy to deploy. It's highly scalable. But another one that I think people tend to miss is because it's a relatively simple language, you can be highly productive very quickly.
Yeah.
So I've found for the most part, I'm about roughly as productive in Go as I was in Python.
Right.
So
Yeah, I forgot to
it's a
mention it.
transition.
Go has 25 keywords, which is half of Java's keywords, by the way. And I think Ruby comes in like 48 or something like that. So in terms of like memory needed to actually understand the language, it's really low. Like you can learn the language very, very quickly. So the adoption rate is very easy.
And some of those codes you don't even need to use on a daily basis.
Yeah, exactly, exactly.
Ramp on time for 2 years.
Right,
Probably hopefully what one you like.
right.
I had this argument 1 months ago. So
Yeah, the ramp up time, when you're talking to the engineering manager, it's the type of thing where you can even sit down and say, look, let's do lunch, and I'll show you over the course of 45 minutes, Go. And you could very quickly show them a few really cool things that Go, particularly, Go routines, obviously, and show them just how easy and simple it is to do, and people get blown away by that, and they get, they're like, wow, we can do all this stuff, and it's actually simple and easy to understand. I can read that code and know what's happening, even though I don't. This is the first time I've seen the language. Yeah, that is a big one. Yeah.
What if somebody is concerned about how many developers, how easy it would be to find developers who can work with Go?
So that is a good question. You're next, by the way, right behind you. So yeah, I've had that question as well asked of me, and my response to that is usually, in 2006, I worked for a startup. I was director of architecture for a startup that was using Rails, and Rails was just about to go 1.0. So there was nobody doing Ruby out there. And so I did the next best thing. If I couldn't find Ruby developers, I just hired really good developers. There was no shortage. Oh, it's a shortage of Ruby good developers, I guess, right? It is a win in the market right now. But you hire a good developer, and a good developer could pick Go up in a couple days and run with it. I certainly had no problem hiring good people and taught them Ruby in a couple days, and they were up and running with it. And now, obviously, everybody's a Ruby developer these days. But yeah, there is a shortage of Go developers. There's a shortage of Ruby developers. There's a shortage of Python developers. There's a shortage of every developer out there right now, the exception of maybe Java developers, which is always a glutton.
There's a shortage there too, especially in the Android space.
Is there?
Yes.
Is there? Okay. See, there's a shortage everywhere, but the true answer is just hire good developers. You in the back, you had your hand up for a while.
I'm not sure what your question is. Is that something like
Generics?
yes, the building blocks?
Oh man, how to explain generics? That might be out of the scope of this conversation. Go is lacking generics. That was the point of that. Yeah, I think the discussion of what generics are is probably something to take offline. It's kind of out of the scope. Somebody else over here had a question?
I was just saying that, like, testimonials are like Russ Cal, like, getting developers learning Go. My first two gigs, like, on like my first job in programming learning Go. So just saying that, like, not easy to learn, especially in C++.
You're
Yeah.
gonna go in 2 days. Right.
Learn Go in 2 days, exactly.
All right, now, I was surprised not to see dependency management on your list. Did you
Yeah.
reject that as?
No, so
Did you?
I was trying to avoid it on purpose. No, the reason why it didn't make the cut is simply that I'm giving this talk next month in GoFCon India, GoFCon Dubai, and they have very strict time limits. So I unfortunately couldn't squeeze everything in there. Yeah, so the dependency management story is a hairy one. And it's still a bit Wild West, as you probably know. They do have that Go vendor thing in 1.6 now. They started at 1.5. It's there in 1.6. There's GoDeps. There's GB. There is no kind of awesome like bundler kind of equivalent. Did I just say bundler was awesome? Oh.
Yeah.
Oh God! Like a little just vomit just came right up about here and right back down again. God, I can't believe I said that. No, God, no. I did not mean to say NPM. Yeah, I mean, the package management situation is most of them require vendoring into your source tree, into your Git repo or your SVN repo or Visual Source Safe repo, whatever you happen to be using. I'm dating myself there a little bit. But yeah, there's no good dependency management. So I didn't put it in there, not because I don't have a good rebuttal for it, but just more for time. But that, and I also don't have a very good rebuttal for it because it still is a problem. And it is still something that bites all of us kind of on a daily basis a little bit, especially if you work on more than one project. Yeah. Other questions? No? Really? Yes.
Just for my knowledge, like, is there projects or applications that you think is not good?
Yeah, I think those small scale websites, when you said you're prototyping a web app and stuff like that, it's just use something like a Rails or a Django, man. Just knock it out and be done with it.
So you recommend like larger scale?
Yeah, you know, first of all, I always say, so I did some consulting for about a year or so with a company out in Cupertino. Redacted is what I usually call them, but you can probably infer from Cupertino what company I'm talking about. And one of the things I was doing for them was prototyping some stuff. And the recommendation I made to them was all their CLI tools should be Go. For the simple fact that it's easy to distribute. You just create that single binary. No one has to install any runtimes or dependencies or what have you, which was a big problem they were having with this particular set of tools. I can't really talk too much about it, but this particular set of tools they had, people had to download a lot of dependencies and set up. They had like custom versions of Perl that people had to install, and it was a really hairy situation. So the CLI aspects got cleared up very easily by using Go. For their web API stuff, their internal stuff, we did in Rails for this project because the internal usage was about 20 people using it internally. And again, it was just easy to do in Rails, very quick to knock out, easy to add a new feature to. But their external stuff, the stuff that when launched would get used by every Apple developer, sorry, every redacted developer on the planet. Is this thing still recording? If they ever launched it, or if the project even existed, I don't know. But say they were to write something that developers would use in the wild, that would be Go, because it could instantly handle the load the minute it came up, and would perform very, very well on small hardware too, limited hardware. So that's kind of the recommendation I live by in life. The project I'm working on at Influx is an enterprise kind of management console for all their products. And that is a closed source binary that people will buy. So while it is a web app, that would have been significantly easier to write in Rails. We chose to write it in Go because it's closed source binary that we could sell and not have, obviously, give away the source for it. So yeah, those are kind of when I would choose Go and anything super concurrent. Like if you're writing an incredible, like the whole pointing wrap is it's super concurrent, don't use Ruby. Any other questions? No one wants to see the old soft shoe? No? Okay, thank you very much for having me.
So I'm going to give you presenter rights.
Ah, okay.
Present to everyone. Yep, and I can share your screen.
Like around 4 o'clock, was that 14%?
If I do this and then I
Oh,
full
yeah.
screen it, I'll just do
Yeah, it'll just, yeah, you can do one window and it'll do,
nice. Going back into the. Okay, cool.
yep, there you go. If you full screen, then you'll be good.
Great.
Yeah, and I'll make a quick announcement and then we can get started.
Yeah, because
Let me run.
I've seen it.
Like,
My phone's.
I'll run to the bathroom real quick.
Yeah.
But yeah, it looks good.
Yep,
Just
it should
hit
be
the hide button. Great.
It's weird. Like,
Okay.
A quick announcement, if you know somebody who is a part of what I would call underrepresented folks in tech, meaning women, folks of color, LGBT, whatever, what have you, if you're effectively non-white male, right? That's what you are. If you're not underrepresented, you're a white male, right? In our tech community. It's an uncomfortable topic at times, but there is a movement. If you haven't heard, there's a movement to try and bring more people, more minorities into tech, right? To have diversity. So one such organization called the Bridge Foundries. You might have heard some events they put around town. So Rails Bridge is one of them. There's a Go Bridge now. Obviously, it's using the Go programming language. I'm actually organizing one such event next month, February 6th and 7th, weekend, for folks to come in and sort of learn a new skill, learn some programming if you want to get into the tech industry and sort of join this awesome people that we are. There's an opportunity to do that. So if you know somebody who fits that description, underrepresented in tech, then please do share. If you hit up the Boston Golang Twitter account, I've been blasting sort of that information onto that channel pretty much for about a week now. So, and I'll be doing that pretty much every day up until the event. So if you know somebody who fits that description, please do share with them. Basically trying to have more diversity, bringing in more women, more folks of minority into the tech community. So please do share. Thank you.
Yeah, I didn't realize it was 2 days, by the way. I didn't realize that today.
Yeah,
Likewise.
2 days. Actually, it started as 1 day, but the folks at the Bridge Foundry said we should make it 2 days that we can move to the pacing in a better pacing.
Oh, so thanks for letting us know. Yeah. Yeah, well, I told Rachel, I think I might be 2 days. Like, really? I'll confirm with Johnny tonight.
It's the same curriculum. But it's split up in 2 days. But, so
it's not like day 2. Day 1. Oh, it's not 2 different groups, 2 different classes.
same group of people.
That is much more.
So what I really want to do is like, I want the first half of the day to be hyperactivity, more of the fundamentals of Go.
Yeah.
Being aware of the
Oh, yeah.
No. You know when you've been doing the Rails for a while? Yeah, they jump you straight to the Rails sometimes, and you don't know what the language
It always
starts.
seems strange to
I don't know why they do that. I haven't done a real.
I've never done one either, but I know that they do that, and it always bumps me.
Yeah, you just start.
Yeah.
Yeah, that's our website now. Like, they do it in Rails, but then they do it in Ruby.
Right.
They can-
I mean, admittedly, that's how I learned Ruby. That's how a lot of people learn Ruby, because they learn Rails, and then Ruby falls out of it. And a lot of people still struggle. Like, I know people who struggle. Couldn't tell you what's active support and what's standard library.
That's right. No, even I experienced that.
Yeah.
I mean, there are times when I'm
Right.
like,
To be fair, a lot of memory support should be on that standard.
Oh, yeah, you know.
I've made arguments to certain people about that as well. That small bits of it, not all of it, but small bits of it. It's fantastic sugar. It's nice sugar.
All right, so let's get this puppy back on the road. So I'm not sure if you've met Chris, but Chris Harway he works at AppNeta. I think he has a very fancy title, which I'm forgetting right now. What's your title over at that?
Chief architect.
Chief Architect.
That's right. I'm building houses all day long. It's crazy. I got the.
Nice. So yeah, so
Blueprint.
what do you do at AppNeta? Like,
So-
what is that about?
AppNeta builds a web app that tells you why your web app is slow. And so we trace the performance of code as it's running, measure connections or queries to databases or to servers or other services or microservices. And we do distributed tracing, basically, where we're following requests as they traverse the different hosts and processes and layers that make up your stack. And then we make a lot of, we do distributed tracing. So we follow requests as they traverse through the different hosts, processes, and layers of your stack. And then we
have a mining issue in real life.
Oh, do I? Yeah, and then we measure everything, and then we show you a lot of latency distributions. Ideally with cool heat maps and stack layer charts, and then you browse the latency distributions, and ideally you spot the performance problem, and then you fix it.
Cool. So fancy monitoring and performance analysis.
Yeah.
Nice. All right. So yeah, I'll let Chris take it away.
Cool. So wait, should I really just stand here and talk towards this?
You can move around, but just if
Great.
you're gonna move around, make sure you speak loudly because we want to put you up on the live stream.
Okay, great. Well, thanks for letting me do this. Secretly, our company has an office in Boston. Wait, there's nothing.
Oh, you're not broadcasting?
Oh, I thought it was.
Dude, no. I'm picking you up on the live stream, but you need to actually.
Screen share. Oh, you know what happens is when I go full screen, it right, and then play.
Is
so it's on yours?
No. You need to be hooked up.
Oh! I thought you were mirroring for me.
No.
I understand. The Hangout is for the benefit of the people.
Of the people not here,
on the internet. Got it. Great. Thank you.
Awesome. There we
Magic.
go.
I thought, right. Yeah. So I gave a division of this talk last year. The secret is that I'm from Providence and I work in Boston occasionally, but so I gave this talk at the Providence Python meetup, and so it's about how I took a service and I moved it from Python to Go, and it used to have a lot of introductory content like how to write in Go for people who write Python, and I'm assuming you all know that already and have already written programs in Go, but I was sort of talking to a more introductory audience, and I'm pretty sure I stripped most of the content that actually teaches you how control flow works out of this talk, but also I'll try to skip over that stuff if it comes up. But so yeah, I was basically talking about this service that I ported from Python to Go. Maybe it's a microservice, I don't know. But and I want to sort of talk about how doing that made my my code not just faster to run, but also cheaper to run, and talk about why that is. So about me, I come from like a systems hacking background where I wrote a lot of C code back in the day, and then I started wrapping things up with Python for tests, and then all of a sudden I started writing a lot more Python, and I really loved it. And then last year, someone's like, you should really write a lot more Go, you should look into this. It sort of hits the sweet spot right between Python and C++ for you, and then I found that it did, and I've been a big fan ever since then. In my case, since I'm the chief architect, I didn't really have to do a big sell to my boss as much as just give it a try and do some research, and I've had a pretty good experience so far. So I've been very excited about that. Yeah, so this is more about the contrasting part of my old talk where I liked a lot of things about Python. It's fun to program. You can write code real fast. You can you get all these built-in types like maps and sets and arrays and tuples that are ordinarily kind of hard to use in C++ with Boost or the STL. There's good library support for whatever you want to do. You just import some stuff, and there's this very simple typing, and you can just write a lot of code real fast, and it's easy to read. The Python comes with this thing where if you type in import this into your Python console, you get a poem. I don't know if you're familiar with it, but it's sort of the ethos of the opinionated part of Python is that it's better to be beautiful and explicit and simple and readability and all this stuff. And I guess the point I was trying to make is that a lot of these things are also in Go. It's not too far off from the goals of the Go language, minus the part where you can monkey patch and hack into any method and class and type however you want all the time and trick people. But the things I don't like about Python, of course, is that it's not too slow. It's not as slow as, say, a Ruby, but it's also not so fast like a Node.js or a Java or a C++. Dependencies are sort of okay. They're sort of a pain. And while it's great to not have any types, it's sometimes hard to know what types you're dealing with when you're reading other people's code, and I always had trouble with that. And then the big thing, of course, is this thing called the global interpreter lock, which is not common to Python. It's in most of the other scripting languages like Ruby or Node.js, but it basically means you can never be computing two different things at the exact same moment. You're always going to be switching or event switching or doing a lot of work like queuing up asynchronous I/O and then going and processing the events that occur, but you are never actually computing two things at once, which is a bummer. So Go, you guys all know about Go. It's great, and there are these people involved in it, and it's fast. So skip that. Yeah, see, this is the stuff. So there's no semicolons in either language, which is a big win for me because I still haven't, my pinky is kind of not been exercised since I started doing Python. And like Python, you also get maps and arrays and strings, and I like how you can just call in the C code when you need to, because I used to do that a lot in Python. And they both sort of have this duct taping idea where you don't have to worry too much about classes. You just inherit from stuff by virtue of implementing the methods that cause you to be the type that you're supposed to be. And minus not having to declare a lot of types makes it kind of easy to just do the colon equals thing. And so you kind of get the feel of writing Python when you're doing some Go. But of course, Go is a lot faster and compiles to binaries, and the memory usage is incredible compared to Python when you're using structs. And the key thing is that Go's got curly braces, which is really too bad. I sometimes worry about how frequently I'm using those characters, which I really don't like using. But the concurrency features are probably the most important part. This is a cool slide I liked. It's sort of going to your talk, talking about the language ecosystem, and this was Brad Fitzpatrick's slide where he's like, well, what's fun and what's not fun, and for some reason Perl is always faster on this list. And I guess that's true. And then sure, Go sort of is not super fun like a Python or a Perl, but it's fast, right? And then they got this other slide where Go is somehow both beautiful and efficient at concurrency, and it's just the best language out there. And so that seems great. I'm all down with that. And then, like I said, these are all the ones that don't have concurrency whatsoever. It's just the global interpreter lock. So I stole the following slides from this talk on Go for Pythonistas, just to sort of talk about what I assume you guys already all know, which is that in Go you use the word go and space, and then you get a new Go routine. I was about to say the word greenlit. See, that's me from Python. But yeah, so you get a lot of concurrency with just 3 characters, G, O, and space. And for me, there's really no language that gives you a thread in such a low amount of typing as the letters G, O, and space. Apart from Bash, where you hit ampersand and hit enter, and you'll get a little bit of concurrency right there. But and then why did I have this? Yeah, weight groups. I was showing off. This is sort of for the Python audience where there's this very similar G-event thing for weight groups. But yeah, you can launch as many as you want, and if you're all of a sudden worried you're going to launch too much concurrency, well then you can fix that as well. And so the example code I was giving was, here's a Fibonacci function in Python that's recursive for one reason or another, and it was sort of showing how you might write that in Python using a concept. You can pretty much write the same code in Go, but where in Python we have this thing called a generator. And the generators are easy to use in the case where you're doing this and you're running the function and you don't even realize it's a generator. And each time yield is called, it sort of carries up all the state that's in the function and then lets you basically have this coroutine style invocation of your code, which is sort of like this. And so this is something that Python people really like, where they're driving the other function without really talking. And you just kind of get this communication loop between the asking the function for its next value. What did I do wrong?
You're not sharing.
I'm not sharing anymore. Well, I was sharing until very recently. It says I'm screen sharing and presenting to everyone. Is it that the window, when it goes full screen, is no longer the thing that is being shared?
You should be sharing your presentation application, not necessarily your window.
I think, am I sharing now? There's participants in Italy, right? I was looking at the comments. You can see it now? Well, I don't know.
Okay, go back to the beginning.
Okay, anyway, so you're driving this execution with your next. In Go, we have, you guys all know this. I don't know why I didn't skip these slides. We have Go routines and channels. And it's similar to the stuff where we were doing with well, the pictures changed, right? It's similar to the stuff where you're driving this remote function by hitting next every now and then. Instead, we're calling receive off the channel, and then there's this buffer and direction in between. And the nice thing about this is, of course, you can choose how much you want to buffer, or you can just cause it to block every time someone tries to send. But it's very similar to the generator concept that a lot of Python people are into, except you get a lot more control over just how much you want to put in the channel and how much buffering you want to do. And so it's nice. And the key thing here is, of course, that you don't need to just have one thing consuming or producing to the channel. You can have hundreds or dozens of things. I broke it. Is it not working?
So whatever we did before.
Got it. So I'm talking.
I bet it's showing now.
Yes. So this is the reason, I think, is because I'm not sharing. Well, now I'm not sharing anything. I should share entire screen because I think I was just showing the window of Keynote before. How's now? Hey!
Now we're good.
Okay. I apologize to the people on the internet. So yeah, that's the nice thing, is it's a lot like generators, except you get this, and then the generator style where you return a channel is the thing that people do. I tried writing all my programs where I return and only consume and return channels, and I love it. It's great. And then this is sort of in the realm of the first talk where I show all the languages, and you see Go's got no semicolons, but it's fast. And then everyone else either has or doesn't have semicolons, and they may or may not be fast. But you know, look at that. It's all mostly green going down the right column. So that's good for me. So why does this matter? Well, concurrency, I'd argue, is, you know, these days much more important than it used to be, right? And so when you're writing for the cloud or using a lot of services, that's very different from having a single socket through which you just do as much as you can. For example, the connection between you and your database, if it's a Redis or a Postgres or a MySQL, generally your latency is all just about how many times you can, or RabbitMQ or any number of, you know, connection-oriented protocols. It's all about how many requests you can drive through that socket. Whereas nowadays you're making all these HTTP-based requests to all these random Amazon services or REST APIs that you yourself have built, and you're running all of these very connectionless things where the latency assumptions all change, and you can't just do 10,000 queries per minute on a single socket anymore. That just doesn't make sense. And so in these days, whereas in the past you had connection-oriented services and you worried a lot about provisioning stuff, now you have a lot of these HTTP-based RPCs, and you have usage-based pricing, where before you maybe were hosting your own servers and you only had this many. Now you can sort of crank things up and down, and it's all about how much you use and how quickly you can use those APIs out there. And so I'd argue that, you know, in the same way as maybe you've gone from RabbitMQ to SQS, or going to Dynamo from whatever KV store you used to be using, you know, you're not using pools of long-living connections so much as you're making as many HTTP calls as you possibly can do in a certain amount of seconds to get the thing you want to get done. And, you know, these APIs are high latency. I've not made in the DynamoDB call that wasn't, you know, more than a few milliseconds. And if you're doing that with Postgres or Memcached or Redis, you'd be like, that's terrible, right? But you just sort of tolerate it because everything's done over HTTPS these days. Which is, you know, bad for your code that's not written in Go. And hold on, I have to hit the hide button because this is really, really terrible. So yeah, so, you know, I used to write a lot of G-event programs in Python, and that's great and all, but at the end of the day, I just can't be doing, you know, two things at the same time with the messages I'm queuing up for myself to process later. I can queue up 100 parallel S3 puts, but I just can't do the SSL handshakes for them or compute the crypto for that. You know, there's a lot of computation involved with actually communicating with all these services. Whereas Go, you can just write as many, you know, Go routines as you want and kick them off, and they will run, and use all your cores, and you'll see the CPU number go to 3,200, and you'll be very happy. This is a Node program that we traced, that my company produces, you know, traces. We just do distributed tracing. So this is a trace of a Node program, and so the programmer is running an Nginx that hands off the request to Node, which renders an express template that invokes, you know, 6 or so parallel asynchronous queries, and then to Mongo and Redis and Postgres and Mongo, and then the profile renders, and then it returns the result back to Nginx. And we see this all the time, but the key thing is that Node is providing asynchronous stuff, but it's not really doing anything in concurrently. It's just queuing up a lot of stuff and then processing it in serially once the query results all come back. So if there's something involving reading rows or reading data that's slow, that's not going to become, you're not getting the true processing of the response from those systems done in parallel. This is a gevent program that I run, and I think the key thing you'll see here is I'm doing all this really cool fan-out stuff that I tell people about, but look at all the time I spend actually processing the results after my crazy fan-out. I'm not, again, parallelizing the computation. I'm only parallelizing the asynchronous I/O. So it's a bummer. And so I'm arguing that in the future, everything's over HPS. So I know these authentication schemes and signature schemes, then you have to JSON or base64 all your stuff before you can put it into Kinesis or what have you. That's a lot of work on top of the asynchronous I/O that you think you're getting, and it's not as simple as just sending a bunch of binary data off rough sockets. So you just can't use those old languages to do all this systemsy stuff anymore. I just don't think that Python, Ruby, or Node.js are going to get you all the way you want to go, because at the end of the day, you want to do 100 parallel SSL handshakes, and that's just not something you should be doing in serial. You should be using all your cores. Yeah, and then this is the point. You should use all your cores because the global interpreter lock is a bummer. So the motivating example for this, oh yeah, strong opinion. In my view, Docker's great, and I love containerization, but I think a lot of the excitement around Docker is because you have this fundamental component written in a scripting language that needs to be replicated in parallel, dozens of times, and also protected from running into memory pools of the other invocations of that same program, because Python's got a pool allocator, and Node, they all kind of grow and grow. So you need to parallelize not by writing a program that can use all your cores, but just by writing a program that can use one core really well and making 32 copies of it. And that's, in my opinion, where Docker sometimes becomes a crutch for scaling a single-threaded service that might otherwise have been written in a concurrent language. So the motivating example for this talk is basically I had this service that needed to put 1,000 items per second into S3. On average, these items are about 70 KB, and I also was storing a record of the file name and the time and stuff into Dynamo for each of these items. So I was making roughly 1,000 DynamoDB item puts and 1,000 S3 puts every second. And that was working okay. And as I was getting up there, I started to think about the cost. Maybe I was at 500 per second, then I got to 700 per second. I was like, I don't know about this, because S3 puts are $5 per million. So that's a lot. That's a lot of money. And then SQS puts are 50 cents per million. That's 10x cheaper, pretty good. Kinesis puts are 1.5 cents a million per 25 kilobyte put units, and it's literally complicated because you need to provision in advance how many bytes per second you're allowed to write. So it's a little hand wavy, but it's definitely cheaper. Puts are definitely cheaper. And then Dynamo, it's all about provisioning how much you use in Hertz month, which is a very complicated metric, but it's the number of things you want to put per month in 1K items, and it's actually kind of expensive. So let's not talk about Dynamo as a place to put 70 KB objects. But what I realized was S3 was not the best place to put 70 KB objects 1,000 times a second. Instead, maybe I should put everything through SQS, which is 10x cheaper for puts, as we discussed. And the maximum message size is 192K, so I'm pretty much OK for most of my messages. And maybe I could figure out how to do it cheaper if I can just write this pink program, the batch writer, and then have it write to S3 every 500 or 1,000 or 100 messages. It makes a larger file of 7 megs or what have you, or 70 megs to S3, and then writes the stuff to Dynamo that had to go there. And what the index, the larger file, would have to basically concatenate all the smaller files, and then I would build an offset map that would tell me the offset and length of each of the smaller files. And then I would just write that to Dynamo, and if I wanted to go find the file, I could use S3 range headers to just read just the bit that I needed from S3, right? And in so doing, reduce vastly the number of puts, but still make the data just as accessible as it was before, since I'm already going through the trouble of writing the DynamoDB S3 URL to Dynamo, and I might as well just add this length and the offset. So the original approach was getting on track to cost $13,500 a month, doing 1,000 puts per second at $5 per million is that much. And then the item writes for Dynamo are actually kind of cheap, just $400. So this is where I was headed if I didn't write this program. And then once I wrote the program or started to think about the model of how good I could get for writing the program, I thought about, okay, I know SQS, you can only receive 10 messages at a time, and you can only delete 10 messages at a time. So that's the best I can do in batching the receives. On the sends, there's no batching. I just have to send one at a time. So right off the bat, I'm going to have to cost me $1,300 just to do all the sends, which is 10x cheaper than the S3 puts. So okay, I'm 10x cheaper already. Now I need to spend another 1% each to do the receives, but that doesn't seem so bad. And then the actual puts now are 10x cheaper, right? Because I'm going to make batches of 10 and put them into S3, and that should be all I need. And then the Dynamo cost is the same, except I am using the DynamoDB put items, the batch put item call, but you don't get to save any money. It's all about the throughput, right? So this new design is 13,000 to 3,200. So that seems pretty good. I'm already 75% cheaper if I can achieve all of these aspirations, right? And the key thing is really that this is the thing that's getting a lot cheaper. Now, let's say I could batch it 100 files at a time, and I could take 10 receives and take the result of 10 receives and then batch that and put it into S3. Well, now I can get it down to 84% cheaper, which is even cheaper than the before number. So I like that, but then now it starts to think, okay, I need a very good and concurrent program. And then, let's say I want to try out Google Cloud Storage because everyone says, well, Google Cloud Storage is more expensive than S3 for puts. Well, it's not important because I'm costing so little for puts now that I'm using the large files. I could probably give it a try with Google Cloud Storage. The secret is you can't. Bytes are so expensive. Out of to the internet from Amazon, it's so expensive to move data out of Amazon that you already lose like 2 months of storage. The trade-off loses you 2 months. Unless you're going to retain it there for like 6 months, it's not going to be a good deal for you. But if you're going to retain your data for like 6 months, you might as well give it a try with Google Cloud Storage. But I wouldn't. It's real slow. Yeah, and so going back to S3, and so let's say I could put 1,000 messages at a time. Well, I should probably not worry about that because it's only going to save me like $50. So let's stick with the goal of batching 100 files at a time and putting them in S3 and retrieving them 10 at a time from SQS. Oh, and then I sort of ballparked how much it would cost to do it myself with RabbitMQ and Dynamo. And I was like, well, if I need 70 KB RAM times 1,000 per second, and I want the thing to stay up for an hour or so before it crashes, and I don't want to go over 50% RAM, and then I just double the instances, for spikes, because in truth, my pattern is like this during the day, and it peaks around 2 p.m. So I don't know. It seemed like it would be kind of expensive, and then the maintenance cost would kind of push it over the edge. So, and then I did a Kinesis experiment. So I was like, what if I had 70 Kinesis shards, which is a lot, and then I, tried to double the number of shards to put in. So I could probably manage it with Kinesis put cost, but then I don't know. It just seems pretty like a lot of work to manage all the sequence numbers myself just to save like $40. So I might as well just give a try with the SQS thing, because the Kinesis thing. Also, who wants to manage 70 shards? That sounds like a lot. So the basic algorithm, and this was honestly 100 lines, maybe 150 lines of Python. Get 10 messages. Have I reached my batch target size, or has a timeout fired? I think it was 130 seconds. And then, okay, yes, well then build the batch file in the offset map, put the file to S3, and write the offset map to Dynamo for each of the items, and then finally delete the messages since I've requested them. And in practice, all of these different operations have different latencies, right? So getting the messages is about 20 milliseconds. Putting them into S3, this is a lot higher, usually from 20 to 200 milliseconds. And then the Dynamo writes are always the fastest thing. But still, the bottom half, the put side, the writer side, and the reader side, the writer side is maybe 10x slower than the reader side. So already I know I'm going to have trouble with Python. Why is that? It's because in Python, I don't really get to do much concurrently, or multiprocess-wise, I can't really get very far. So I can basically just write a giant while loop around this, right? And in Python, I was able to get this to go up to about 50 messages per second because the whole loop was, was about that amount of throughput for the whole system. But once I tried to crank it up to that target of 1,000 per second, all I could do was add more processes to my system, right? Because there's no good way to share work or to have concurrent writers or readers in Python unless you want to go into crazy IPC hell and start writing multiprocessing based programs, or doing a lot of non-shared memory based memory sharing. It could be kind of dangerous. And so the key takeoff was that it was impossible to scale the number of pollers and writers independently because each program was itself its own copy of this simple algorithm. And each of the batches were much too small. Like I could never actually achieve 1,000 messages per batch because I was running 50 of these processes to keep up with the load. And so each batch was 50x smaller than they ought to be. And so I was also not maxing out the number of messages because I was over provisioning writers to make up for the fact that that the writing side was like 10x slower than the reading side. So it was really hard to, and then if I did under provision readers, it was hard for me to tell if I was falling behind because write latency was harder than read latency. So I was like spending all this time worrying about the right side, and then all of a sudden I would realize, oh gosh, SQS is full. And so this was not so fun. And then I ended up re-implementing it in Go. And as you can see, there are these nice things called channels, right? And so I could pick as many SQS pollers as I want and independently scale the number of writers as I wanted just to fit exactly the workload. And then I had this middle thing that ensured that every time I made a batch, it was exactly the size I wanted, and it was gulping down from all of the different SQS pollering Go routines as necessary. So there was no, unlike with this system, everything was shared, and I was always hitting my targets. And so that's sort of the lesson I learned, is that the concurrency model your language provides is really important if you're doing all of these high latency API calls. And if you don't have a language that can help you to scale each component or each communication between each component as necessary for that workload, like S3 has very different timing characteristics than Dynamo, which has very different timing characteristics than SQS. If you can't scale all of the clients to those services independently, then the magic glue code that you're trying to write to orchestrate all of these communications is just going to lead to over provisioning or one in the service that is the fastest, or the service that is yeah, generally the thing that's the fastest is going to be over provisioned, and then you're going to be just able to keep up with the thing that is the slowest. And as a result, when you're using a usage-based price-based API, it hurts you monetarily because I am making way too many SQS calls here just to get some kind of batching on the S3 side. Whereas in this case, I'm only getting as many SQS messages as necessary, and pretty much they're always 10 or so. They're upwards of, well, I try to make it so that they're auto sizing the pool. It's kind of fancy, but I'm trying to like change the pool size as I expect the load to go up and down. But yeah, the result is without that type of fine-grained control over concurrency, you end up with suboptimal costs. And so this, again, is for a more general audience, since I'm assuming you already use Go, but maybe you're asking yourself, does this apply to me? And I would say, yes, it definitely does, because as we move forward, there's going to be more cloud and more cores and more need to use the cores to talk to the cloud in the future. Everyone's talking about services, microservices these days, but I remember when they were just called services, and the acronym SOA was very popular, but now it's less so. But the point is, do you have code that calls multiple independent services serially? And this is a question I ask a lot of programmers who write Ruby or Node or whatever. Well, not so much Node, but Ruby or Python. I say, do you call like one thing and another thing, or PHP? Oh my God, they do this all the time. Do you call one thing or another thing? And they're like, yeah. And I'm like, well, why? And they're like, well, because you have to put them in order in your program. And I was like, guess what? You don't have to. You should be doing this as much as possible, or else your customers and your users are waiting for that time. And they were like, oh yeah, I guess it is my language, because it's just not easy enough to do so. And the real answer to why is just because you don't have magic geo space syntax to just go and create a Go routine when you need one. In Python, I can't imagine how hard it is to do so. In Java, actually they have this new thing in Java where it's a little easier, but it's still kind of a pain, and you gotta make a run method or a runnable or a thread or a thread object or launch a p thread. And maybe you're saying, okay, well, great, Chris, I agree, scripting languages are bad, but I write in one of these better languages. Couldn't I just use that to achieve my multi-core concurrency? And I'll say, well, sure you could, but it would kind of be a pain to spawn new threads. I would still think geospace and the function name is the quickest and easiest way to get concurrency in any language, hands down. And also, C++ and Java have a pretty heavyweight thread size compared to Go. Like, you can really look up to tens of thousands of threads, whereas with Go routines, I'm typically running programs that go to hundreds of thousands or millions of Go routines, and it seems to mostly work all the time. Unless, yeah, more or less, it's always fine. And yeah, the thread size has been very, very successful in being able to just parallelize stuff. And then we'll be like, well, how about if I did it times 1,000? And you know, you're like, oh, yeah, that was it. That was faster. Cool. And yeah, and I think Go and Erlang both are sort of designed around having very lightweight threading so that you can do up to millions of Go routines on a 64 gig RAM box. So I would say that's why you should not use Scala, because it's heavier weight threading, unless there's something I don't understand about Scala that I'm not describing here. But anyway, I want to thank you all for listening to me talk. I hope this was interesting. And yeah, we're always hiring engineers in all of the places where we currently employ engineers. Cool. And yeah, if you have any questions, I'd be happy to answer them. Do I have another slide? I don't.
I got a question.
Yeah.
You said you considered slapping Rabbit in there.
Right.
Did you consider just having a fully Go solution, or if not, why?
Oh, doing the queue myself.
Yeah.
Yeah, the thing producing the message is not written in Go.
Oh.
The thing that was putting the data on S3 was originally doing it from this whole other service somewhere else in Python. Yeah, I was thinking, why don't I run my own queue, right? And I could use some RabbitMQ, which is written in Erlang and seems to be, or a channel. Well, you need to make it a server. Yeah, okay. Yeah, the thing that was doing the sending is not a service that's written in Go. And so I needed to think of a way to interpose what used to just be a very fast S3 put with a similarly fast SQS put, and then write this pink thing. But I did not change the blue thing, although I am currently working on the blue thing. So that's good, right? The blue thing is a fair amount of more code than the pink thing, which was started as a 100-line Python program. But yeah, no, the blue thing could really benefit from concurrency as well. Yeah. But even so, there's something to be said for systems like SQS, because they protect you against provisioned throughput-based exceptions, you know, because SQS is, it's got no provisioning, so you can just kind of use it as much as possible. So it's good for bursty stuff. Whereas Kinesis or Dynamo will give you errors if you try to put more than the provisioned amount per second in. SQS will just take everything you give it. And so in a lot of places where I need to buffer or prevent myself from getting in trouble, if all of a sudden there's a spike in traffic, I often will use SQS as like a place to just throw stuff if stuff's down. And it's nice for that. It's a little expensive, but it is pretty nice for that. Any other questions?
Cool. Thank you.
Cool. Oh, and to answer your question about what people did with generics in assembly, this is what they did. It's called this. I used to have to edit this stuff. You can make anything generic with this, but you don't want to. It's terrible.